OSU Food Science and Technology Department's Farm to Fork webinar series. My name is Sherry Cole. I'm the director of OSU's Sustainable Food Manufacturing Program, and I'll be your moderator for today. First, I want to thank you for taking the time to join us. We know that you're really busy, so we really appreciate your interest in the stories that we tell in this series. Our intention with the series is really to expand the conversation about how our food systems work and really how they're changing, why that change is happening, and ultimately about the people who are helping to create that change. Our goal is to really bring you a diversity of stories that illustrate the diversity of how our food systems work and the people behind them. First, before I introduce today's presentation, I just want to briefly run through some logistics. First, we're recording the webinar, so it will be posted on our Farm to Fork website afterwards for you to either review later or share with others. We encourage you to do that. The other thing is we do want this to be as much of a conversation as it can be. And so we've reserved the last 15 minutes of the webinar today for your questions. So if you look at the bottom of the screen, you'll see the Q&A tab. Click on that throughout the presentation and put your questions in. And then if you see questions in there that you're really interested in, then click on upvote and those will rise to the top, and then we'll cover those during the Q&A session. So it's my pleasure today to introduce today's presentation, which is the future of hemp utilization and its role in the food industry. Please welcome Paul Hughes.
You're muted, Paul. Can you please unmute your microphone?
The bar moved. Sorry about that. Good afternoon.
Thank you.
Thanks for coming today to hear me talk a little bit about hemp, particularly in terms of its application in food, potential applications and historical applications that have been in the system for thousands of years. So it's a versatile ancient new crop. It was used for fiber, paper, even high-end papers, medicinal and ceremonial uses. And I'm not going to talk much about the medicinal side today, but you may have seen in the news that Linus Pauling Institute here at Oregon State have found that CBD encourages the immune system to fight COVID-19. So that seemed to us pretty big news, but I'm going to keep right away from that subject, apart from just mentioning that. It's a new crop in as much as hemp has been subject to a whole raft of legislative restrictions in different parts of the world. And as it's become more and more decriminalized, the commodity is actually trying to catch up in terms of what we understand about its properties and applications. So I'm going to focus on food today, and we'll look at sourcing foodstuffs from hemp, and then the various hemp seed components that, in particular, that are of use to the food industry, and then some future prospects. So one of my colleagues calls hemp the equivalent of the Native American buffalo, in as much as you can use pretty much all of it for some sort of application. Over on the right-hand side of this scheme, you can see plant stalks, decortication. So you can generate products like hempcrete, which is a very light, it floats in water, construction material that is fireproof, essentially. So there's all sorts of other applications of hemp that, if you're interested, you should really look into. But what I'm going to focus on today is the food side of things. So the grain or the hemp seed, and some aspects of the plant biomass, particularly the essential oils. Just give you some idea, relative production of hemp around 2017 to 2019. You can see half is grown in North America, and perhaps a third in China, and the remaining sixth in Europe, particularly France. There's around 114,000 tons of hemp seed produced every year, and that's on a par with alpha acids used to make beer bitter. It's about 100,000 tons. It's a relatively small commodity right now, but I think in the future we're going to see that that grow rapidly. As I mentioned earlier, China has the perhaps the most venerable history regarding use of hemp, but Canada is a big grower too, and we'll see the USA, I'm sure, play catch up there. So seeds, crushed or whole, they're used in traditional Asiatic foods and medicines, even to this day. It's only within the last 10 years that we can legally use hemp seed in foods in North America. If you're going to use them, I suggest add them to muesli or salads, and even crushed, add to baked goods. They've got a rich nutty flavor and can be used as substitutes for pine nuts and sunflower seeds. And I just, for interest, looked at Amazon the other day and typed hemp cookbook, and there's pages of them. So bit of information overload, I guess, trying to find the right book for your needs. We call it hemp seed, but it's defined as a nut. That's a seed with a tough shell that doesn't open, as opposed to a seed that will open out. And it's rich in nutritionally relevant materials, as we'll go through. This is a specific Finnish variety that there's been a lot of work done on. And 100 grams of hemp seed gives around 500 calories. That's probably a third to a quarter of what an adult male would need. So it's actually quite nutritionally dense, but I guess it's a bit tedious to munch through 100 grams of hemp seeds. We've got plenty of fiber, either digestible and non-digestible, both good for gut health. And ash includes things like minerals and calcium and phosphorus in particular. So there's all sorts of ways we can process. The crudest, I guess, is take hemp seed. We can take the shell off the seed, so take the hull off if you like, or you can toast them, and toasting gives a more that sort of cooked, almost malty flavor. Can either separate the oil, which is basically fatty acids, from the remainder of the seed, which is going to be mostly protein, so about a third protein, and then that can be worked up to make a higher protein concentrate. I don't want to get too much into details of nutrition, but some fatty acids are classified as omega-3 and some as omega-6. And that ratio is considered by nutritionists to be optimal at around 3. And as we'll see, hemp is pretty close to that. Low in saturated fats too, which is good news. This is a sort of sophistication that's applied to isolating oil components from hemp using something called supercritical CO2. So carbon dioxide is a clean solvent, leaves no residues. But to operate supercritical CO2, you need certain pressures and temperatures. And we recently took delivery of a device that will handle up to 9 kilograms of hemp per run. So we're looking forward to playing with that and isolating our oils and other components. So if we take oil from the plant itself, it contains all sorts of exotic sounding chemical compounds. These are known as terpenes and terpenoids. And if you have any experience of terpenes and terpenoids, you'll note that all of the compounds listed there are not unique to hemp. They occur in many, many other plant materials. And that's a general feature of essential oils in plants. There are very rarely compounds unique to a given plant. So hazelnuts contain a compound called filbertone, but generally alpha-humulene, for instance, you'll find in hops and juniper. Beta-pinene you find in wood. Myrcene is a major component of hop oil, and 1,8-chineol is the koala bear's favorite. It's eucalyptus aroma. So many essential oil compounds that are that can be used in flavor applications. I wonder whether I can make a gin and tonic out of hemp seed oil. In terms of fats, the major fatty acids are linoleic acid and gamma-linolenic. They're just names. They're the omega-6. And the alpha-linolenic and stearidonic acids, omega-3s. And that ratio in hemp, from the literature I've looked at, ranges from 2.5 to 3, and 3 is thought to be optimal. And the saturated fatty acids I mentioned before, which are generally not so good for health, certainly not in high levels, present in low proportions, which is classified. If we look at fatty acid profiles from other seeds, we can see that N6 to N3, N is just another way of putting omega in. We've got oil hemp seed 2.5, and then we see some of the other ratios there, evening primrose and sunflower oil, and borage well over 100. Soy is pretty good, and canola, rapeseed, is not too far away. So this is, again, this points to the high nutritional quality of the fats in hemp seed. Now the proteins are really interesting too. The two main proteins, edestin it's by far the largest proportion of protein. It's a globular legumin, and this is an example of something that is unique to hemp seed. Albumin's also there. We find albumin in other plant materials. But the nice thing about these proteins, particularly edestin, it contains really decent levels of sulfur amino acids, one of which, methionine, is essential, as well as high arginine and glutamic acid levels. And arginine is one of those amino acids that is thought to be implicated in the release of nitric oxide, which was relatively recently discovered to be a vasodilator, so helping blood flow. And this gives you an idea of what the soy, hemp seed, and egg white protein looks like in terms of amino acids. The asterisks at the bottom here indicate essential amino acids. In other words, amino acids that are that we can't, or we can only produce with difficulty in our own bodies, so we have to consume them from outside. And as we can see here, arginine is, relatively speaking, off the charts. And we see good levels of, so methionine, as I mentioned before, cysteine, the other sulfur amino acid. So again, containing a quarter of the hemp seed is protein by dry weight. So a rich protein source for food applications. Now, edestin is highly digestible. And what that means is that's when we take a protein and our body can break it down into its component amino acids. And we can then reuse those amino acids to build proteins that we need for our body. Another interesting feature is that edestin is thought to be a factor in DNA repair. DNA repair is an essential mechanism for retarding diseases, certainly cancers and so forth, that because once DNA fragments, then it starts interfering with the genes that are required for our protein synthesis to keep us healthy. So again, makes me think that Destin should be one of our 5 a day. Other things that we can find in hemp seeds, well, there's the vitamins, thiamine and riboflavin, B1 and B2, really needed for carbohydrate, protein and fat metabolism. Vitamin E is an antioxidant, it's a fat-soluble antioxidant that can help against inflammation. And then we've got minerals such as phosphorus, which is essential for nucleic acid synthesis, potassium for nerve health, and salts such as magnesium and calcium, which are essential cofactors in many biochemical systems. Sodium is low, and you'll find that in unprocessed plant products that sodium will almost invariably be low, because sodium interferes with water uptake in plants, so plants actively avoid it. That's why you don't see many plants growing on the beach. Some have adapted, but plant materials are generally low in sodium. So what about the future? Well, as I mentioned earlier, hemp's highly unusual because unlike other agricultural commodities that have been studied as science has developed, there are, relatively speaking, few rigorous studies on hemp in all its forms because of its legal status. I used to live in the Netherlands, in a city called Leiden. The University of Leiden has been around since the 1400s. And a good friend of mine started one of the first hemp programs there. And he told me that the biggest problem with that was finding an honest gardener, which I thought was, that was in the 90s. And they still to this day do work there. The legal situation is fluid around the globe. And even in the US, it can be a little tricky in as much as, for instance, in Oregon, the state declares it legal for medical and recreational use, but federally it's not legalized. The clever money says that probably by 2030 it will be completely legalized across the US, with perhaps 1 or 2 intransigent states. I think my personal opinion is that I think Oregon were quick out of the gate after Colorado to legalize, and you may or may not know that the OSU hosts the Global Hemp Innovation Center, which recently scored a $10 million grant to explore environmental requirements for hemp production. The other thing, a couple of points I just want to touch on before we close. In 1938, there was this article published in Popular Mechanics that called hemp the billion-dollar crop. But then when the legal challenges came along, the petrochemical industry was really starting to go gangbusters with the development of the internal combustion engine at the late 19th, early 20th century, and the fractionation of crude oil. Ironically, now we're looking at hemp as a replacer for oil-based products. Also, this is an igloo, if you like, built out of hempcrete on the bottom right there. And the part of our project that we're working on over the next 5 years will be exploring some of these products, particularly hempcrete and textiles. So I hope you agree with me that hemp seed seems to be an excellent source of nutrition. Modern clinical trials seem to say that there's some health promoting properties, which is supported by the nutritional analysis that can be carried out. Certainly plenty of essential and polyunsaturated fatty acids, and a good balance of essential amino acids. And I think in the future we're going to see hemp cultivated specifically for higher quality fiber, seed, and oil composition. So with that, I'd like to leave it there. And if anyone has any questions, feel free.
Thank you, Paul. It's a fascinating topic, and I know that it's really a dynamic one. So thank you for coming and helping us understand just the current state of thinking about hemp's role in food. Thanks to those of you who've posted questions. If you have others, please go ahead and share them now. Mike asks, what climates favor hemp growing?
It grows in a wide range of climates. And one of the aspects that we're looking at here at OSU is planting a selection of varieties or cultivars along the west coast, I-90, Route 97 we call it, to see what the interaction is between environmental conditions and variety. So I think then we would get a much better understanding. Hemp plants take about 120 days from planting to harvest. So even in inclement winter conditions, we can avoid those situations and grow in the warmer weather. I wouldn't try it in Alaska though.
Thank you. Ellen asks, how large is a hemp seed? Since they have similar flavor profiles to pine nuts, would they be a good substitute for how pine nuts are used, for example, in pesto?
Yeah, good question, actually. I meant to put it on my slide. It's about the same size as a coriander seed. So 4 millimeters, let's try and convert it into inches, 1/6 of an inch in diameter, something like that. So smaller than a pine nut. I wonder whether we could use it to make a sort of a product like tahini, which is made out of sesame seed. That could be quite an interesting experiment.
Thank you. Mike asks, how is hemp used today in food, whether that's in the US or elsewhere?
Yeah, it's a good question. I think the food applications are only slowly coming about following the decriminalization of hemp. And certainly across the globe, it's used in cooked savory products, I would say mainly. But given I've never actually tasted hemp seed, but given that it's reported as being rich and nutty, are very common flavor descriptors, I could see it being applied in products as diverse as ice cream and savory sauces for food.
Thank you. Jim has a couple of questions. The first is, where on the hemp plant are the seeds?
Oh, good question. So I should have shown a picture of a hemp plant, actually. They tend to go, yeah, how do I explain this? Not being a biologist, I'm sort of lacking the vocab for this. Where you get branch points on the plant, the seeds tend to nestle there. And the reason for that is that what the plant wants is for them to fall off and make little baby plants. And so one of the things that we're looking at is how we break down the hemp plant to separate the seeds from the fiber, etc., so that we can look at their various applications. But they're pretty loosely in the buds, I would say. So if you take a bag of hemp buds, if you like, and shake it, you're likely to find that some of them deposited at the bottom of the bag.
Thank you. Jim, second question is, what is the weight by percent of the plant versus for the seeds?
That I don't know. I'd have to look that up.
Thank you. Retha asks, what types of processing cause the least destruction of nutritional properties?
Okay. I would probably, so some of the processing is aimed at concentrating up a specific nutritional factor, such as I showed on that scheme with proteins, enriching hempseed powder to separate protein from other materials, particularly the hull. I would say that probably to get the most nutritional benefit, you probably want to crush the seeds in some way. If you don't crush them, you do preserve the nutritional benefit. But I think, like in our experience with other seeds, your body's going to struggle to break down the hull around the seed. So you get much less nutritional benefit from that. On the downside, if you mill or crush them, you probably need to bear in mind that they'll have a shorter shelf life, particularly because of the unsaturated fatty acids, which are relatively easy to oxidize. So a bit like having a coffee grinder, grind a little and often rather than grind up your 10-pound bag in one go.
Thank you. Hillary's question is, please talk about using hemp in animal feeds, perhaps, instead of soy as an alternative to soy.
Yeah, in fact, that's really a good question. Right now, there are feeding trials for cattle going on at OSU, where not just for nutritional benefits, but also the impact of CBD and not THC, we avoid that, but in so-called industrial hemp, which is defined as having less than 0.3% THC in the plant by weight. So there are a lot of opportunities for use in animal feed. The gold standard is a feed additive that can be fed to baby chicks. That seems to be the most delicate animal feed system. I haven't seen baby chick feeding trials, but certainly cattle seems to be a good option. But to be perfectly frank, if it's a human, if it becomes popular as a human feedstuff more globally, then that will increase its value. So if I was growing hemp for feed, if I could grow it for humans, I would probably make more money than growing it for animal feed. But anything that's perhaps doesn't work for humans nutritionally, that could be fed to animals, I think that's the way around I would look at it.
Thank you. Hamza asks, is it true that hemp seed is anti-nutritional since it contains considerable amounts of phytic acid?
Good question. It does have phytoestrogens in there, which have a sort of a two-edged sword in terms of health benefit. Usually when we think about anti-nutritional, we're thinking about tannins that bind with proteins to stop our body digesting protein. You know, I mentioned the intestine was highly digestible. Tannins tend to make proteins less digestible and therefore restrict their nutritional status. So yeah, pretty much all plant materials contain tannins. So I would expect there to be some anti-nutritional properties of pretty much any plant material that we consume. It's a question of degree.
Thank you. Mike asks, do the seeds contain CBD?
No, not as far as I'm aware.
Okay, thank you. Sean asks, could you speak more specifically about the research that you're doing with hemp?
Yeah, so it's a multi-center project that started off at the beginning of the year, that's running for 5 years. Where we're going to take 4 varieties and plant them in 4 different areas. So 4 different plant types in each of 4 different geographical locations, and harvest them. The first harvest, I think, will be in September or August, September this year. And my specific role there is to extract the oils from the plant material, and then those oils will be fractionated so that we'll have the cannabinoids and the essential oils, and the CO2 extractor can pretty much quantitatively separate those in principle. We'll see how that goes when we really get going. And then, for instance, we'll be sending fractions to pharmacy and Linus Pauling Institute, and they'll be running tests on these various fractions. The engineering school is looking at fibers and construction materials. And so we hope by the time we get to the end of these 5 years that we're in a position to really understand where the value chain or chains lie when we're looking at growing hemp, and what properties seem to be the most valuable. There is another side to it, which College of Business is looking at, which is logistics. So if we're planting hemp in various locations, where's the most convenient place to process? We know drying can be a bit of a variable process. So maybe drying needs to be carried out close to the hemp field, whereas extraction maybe can be localized a bit further away. But of course, we want to try and it almost becomes an operations research project. Does that answer the question?
Yep.
I may look at essential oils as an ingredient in botanical spirits like a gin, but we right now we're avoiding THC and CBD products for obvious reasons.
Jim asks, can hemp seeds be used like caraway seeds are used in bread, for example?
I don't see why not. Again, I may just crush them a bit. Otherwise, I think they're a bit too large to chew comfortably, and you don't want to break any teeth. If you've ever tried to bite coriander seeds, they're pretty hard to get through. But if you soak the hemp seed, the husk should become much more pliable.
Okay. Richard asks, are there other extraction methods besides supercritical CO2 that are used?
Yeah, so my background is chemistry, and so it always gives me the heebie-jeebies because liquid butane is a common extraction solvent. It's very good, but obviously it comes with some risks, fires and explosions. And you really want to have a closed system. You don't want to be venting that into the atmosphere, not in significant quantities anyway. I have been told that butane extraction is useful for extracting plants that have picked up a bit of mold growth, in that it doesn't extract those much of that mold flavor and aroma, those musty type compounds. But I think supercritical CO2 is a better way to go. I'd be surprised if ethanol wasn't used as well. But hemp is most closely related to hops in the plant world, and certainly hop extraction with alcohol or ethanol is is performed not widely, but in Germany, for instance.
There's some questions about just sort of the commercial, the state of the current commercial situation. So can food companies buy hemp seed or oil or hemp derived products now in the US to use in food? Are there suppliers of it?
Excuse me, sorry. Hemp products are certainly available commercially. They're grown commercially. I was actually talking to a hemp extraction company in Hood River. They extract 2,000 pounds of hemp a day. That's a ton, basically. But he told me that he hasn't extracted for 8 months because of the price fell through the floor. So there is something going on there that in the market that is actually damaging hemp growers at the moment. Quite when that will rebound, I'm not sure.
So is hemp traded as a commodity like other ag products, corn, soy, etc.?
Yeah, it's from. I mean, there are hemp farmers out there that are selling and trading. So even if you drive down I-5 between Portland and Corvallis, with the windows open, you can often smell the hemp plants as they're growing in the fields.
Do you have a sense of what an equivalent cost would be? So hemp seed would cost 10 times more, equivalent to, I'm trying to just get a sense of what the state of the market is like at this point.
Yeah, I haven't looked at that, to be honest. And obviously a pertinent question, but I would say the market is pretty volatile at the moment, so it's difficult to know exactly what those costs are. I can try and find out, but I don't have a sense of what that might be right now.
You've talked about functionality of hemp derived materials in food. Are there other attributes that are being evaluated? So, for example, do they create off flavors in food? Is there work on trying to stabilize shelf stability of the oils, for example?
Yeah, I think we can import a lot of knowledge from other ag commodities, for instance, on oil stability. There's huge amounts of work that's been carried out on relative stability to oxidation of the different fatty acids, for instance. So I don't think we need to reinvent the wheel in that sense. And I forgot what the first part of your question was, sorry.
Just if there are other avenues of
Yes.
research just on different functionality attributes of hemp derived products.
Yeah, so some of the major car companies are now using hemp products in some of their manufacturing some of their inventory. Side view mirrors, for instance, the box that the mirror comes in, if you like. So it's Mercedes, Porsche, I think Toyota are all using hemp products to try and start replacing oil-based products, so reducing their reliance on oil. I think it's going to be a tricky one, just because we're so reliant on polymers that we're really familiar with, and I'm not quite sure how we're going to faithfully replace those with hemp-based product. I think hemp will be part of the solution, but I think there'll be others. We need to look at other options as well.
A couple more questions. You mentioned at the beginning of your presentation the geographic production of growth and production of hemp. Has China been growing hemp longer than the US? Do you have a sense of that?
Yeah, archaeologists reckon that China's been growing hemp for medical and rituals, so forth for nearly 9,000 years. So they've certainly got the jump on us in that sense. I would say knowledge base wise, probably China and the US are probably ahead of the field, the Dutch as well. But yeah, they have a long history of it.
And then last question, you may have referenced this, but are there limits on the kinds of research that can be done in the US on hemp? And is that regulated by states or by the federal government?
Well, let's put it this way. My understanding of the OSU's stance is that we restrict our research to industrial hemp. Although I think from a medical perspective, I think pharmacy and Linus Pauling will be doing other research. And the challenge is that OSU is a land grant university, and so we're supposed to be supporting agriculture in Oregon. And since it was decriminalized, hemp has become the largest agricultural commodity in Oregon, which isn't bad because there's over 200. So we've sort of caught, and OSU is gained significant funds from federal sources. So to be seen to be working on something that's illegal at federal level, it obviously carries a risk. And so the industrial hemp route was considered to be a good compromise. I think given the way things are going, as I mentioned earlier, by 2030, it's commonly felt that it'd be decriminalized federally, and then it'll be up to states to decide whether they decriminalize or not.
Thank you. Well, thank you so much for your presentation.